Okay, what we're going to do here is apply some trigonometry to a problem. And the problem you can see is down the bottom here. A plane is flying at an altitude of 1500 metres. So here's our plane at 1500 metres. You can see that it's vertically off the ground. The ground would be down here somewhere. And it starts to climb. So it's climbing at an angle of 15 degrees to the horizontal. So this is going to be the path of the plane. Now it sees in the distance, 2,400 metres off, a mountain. And the mountain is 2,120 metres high. Now that is not this distance here. What we're trying to calculate is whether or not the plane will actually clear the mountain. And so to find out what altitude the plane will actually be at the mountain, which is 2,400 in the distance, what we're going to have to do is add the 1,500 metres that it is currently at to the distance that it's able to climb. So the plane is climbing over the next 2,400 metres as it moves along this path. And so we'll be able to add the 1,500 to this height, and that will give us the height that the plane will be at when it reaches the mountain. And if it's bigger than the mountain, if it's taller than the mountain, then it's going to clear the mountain. But if it's not taller than the mountain, then it will not clear the mountain. So what we're going to need to do is find this distance here, which is the distance that it's going to climb over the next 2,400 metres if it's climbing at an angle of 15 degrees. So this is something that we can apply our trigonometry to. So you'll remember once again that we've got our memory trick, our SOHCAHTOA, and in this case our angle is 15 degrees. And so when you look from the angle, we've got an adjacent measurement, because here's our right angle, there's our adjacent measurement, and we're trying to calculate the opposite measurement. So we've got the adjacent and the opposite, and that means that we're going to need to use the tan ratio to calculate x. So let's write our equation. The tan of 15 degrees is going to be equal to the opposite over the adjacent. So the opposite is x, and that's over 2,400. If we now want to calculate x, which is what we do want to do, we will need to multiply the right-hand side by 2,400, or 2,400, and whatever we do to the right-hand side, we have to do to the left-hand side. And so that's going to give us on our next line 2,400 times the tangent of 15 degrees, becoming equal to x. So I'm going to switch these around now and put x on the left hand side and say that x therefore is equal to, and this is where we grab our calculator, we turn them on, and we say 2,400 times the tan of 15 degrees, and that's going to give us 643.08 metres. Remember our current measurements. I should have actually put the units on right there. Our x is equal to 643.07 metres. Now we need our plane to be taller than the mountain. You'll remember that at this point here, okay, if you look at the graph down below, at the current point our plane is 1,500 metres off the ground. And so it's able to climb 643 metres in that 2,400 metres travel distance. So the total height, or the height that our plane is actually travelling at, is going to be given by 1,500 plus 643.07, and that's going to be equal to 2,143.07 metres. And you can't see, let's turn off the picture. There we go, 2,143 metres. Now our plane, if we bring our image back on, our mountain is 2,120 metres high, 2,120 metres, and so our plane is going to clear our mountain with 23 metres to spare. And so that way we can answer our final question that yes, the plane will clear the mountain because it's going to be at an altitude of 2,143 metres, and the mountain is 2,120 metres.